Okay, so to finish off chapter 3, we'll go over 3.6, which is closely tied to the things we mentioned in 3.5. And so we take the conditional statement that we talked about in 3.5, and again, we're looking at different angles of it and different ways that we can reword and twist that statement. And two that we'll talk about here in 3.6 are the inverse and the contrapositive. So we've already talked about the converse of the conditional statement, and now we're talking about the inverse and the contrapositive. So there are some things to keep track of here, but again, when we're looking at how we reason and how we process things and how we set things up with logic, these different statements, the different ways that we can position this, that's what's involved in things like proofs and trying to, when we're looking at different theories and conjectures and all these things that are used in reasoning throughout math and science, this is very much a part of that. So the two things, again, inverse and contrapositive. The inverse is a statement that where we take both the hypothesis and the conclusion, and we keep them where they are. We don't switch the location of them, but we add a not in there, and that's what it means when it says that we're negating both the hypothesis and the conclusion. So we add a not in there, and that's how that looks in the statement itself. And so we're back at the example. If a number is even, then it is divisible by 2. The inverse, you can see the nots are added there. If a number is not even, it is not divisible by 2. So we see what the inverse looks like in that case. So very, I guess, one step away from the conditional statement, in a sense. We're just putting a not in there. Just like the converse was one step away, but we switched the hypothesis and the conclusion. The contrapositive is the combination of both. So if you notice here in the contrapositive, we're negating both the hypothesis and the conclusion, but not of the conditional statement, of the converse. So we have to obtain the converse first, and then we put the nots in there. So yesterday we talked about, or in 3.5, we talked about the conditional statement and the converse. Well, the inverse is when we negate the conditional statement. The contrapositive is when we negate the converse. So when we add the word not to the converse. In the inverse, we're adding the word not to the conditional statement. So let's actually see what these statements would look like in an example. And so we see the first example. If this year is a leap year, then February has 29 days. And actually this year was a leap year, 2020. So if this year is a leap year, then February has 29 days. So we want to look at the the 3 things, I guess, to determine what's positive and, what's true and what's false. So the first thing here is the statement itself, so the conditional statement. That is the one that is in the example, right? If this year is a leap year, then February has 29 days. I'm going to rewrite it just so that we can have the same formatting for each of the things that the example asks for. So the conditional statement, again, I'm rewriting this here. Maybe I'll use a different color for that. So if this year is a leap year, then February has 29 days. So there's our conditional statement, again, coming right from the question. So determine if it's true or false. So remember, we determine if it's false if we can find a counterexample. But one of the things that makes a leap year is the fact that we have that extra day, and that occurs in February. So we know this is true. We're not going to have a leap year unless February is going to has 29 days. So if this year is a leap year and February has 29 days, this is true. Next one, the inverse. So the inverse, you look up above in the notes, you think about what that means in this context. Well, we add the word not to that conditional statement. So if this year is not, and I'll underline that, is not a leap year, then February does not have 29 days. And we think about that as well. And it's we can kind of go in circles here, kind of get dizzy a little bit sometimes thinking about this. So we take it slow and try and process each part of the statement here. So if this year is not a leap year, for example, next year or last year, since we've lived through that one already, 2019, not a leap year. You look at the calendar, February does not have 29 days, right? So if this is not a leap year, February does not have 29 days. And that would be the case. Again, because the leap year and the 29 days of February, those are closely connected. So if it does not if it's not a leap year, then February does not have 29 days. So this is also true. And then the last one is, in this question anyway, is that contrapositive. So we talked about how the contrapositive is the when we negate or we put the not, that word not, into the converse. Well, another way of looking at it is if we take the inverse, the one that already has the nots in it, and then we flip it around the hypothesis and the conclusion. So instead of going converse to contrapositive, you can also think about it coming from this, the inverse here. So we have the inverse with the hypothesis here and the conclusion here. We're going to flip that around now, and we have our contrapositive then. So if February does not have 29 days, then this year is not a leap year. And again, try and make sense of that. Well, think about if you're in a February right now and you look at the calendar, if it does not have 29 days, then you know it's not a leap year. So this is also true in this case. So if we're looking at what's true, we're trying to find, or if it's false, we're trying to find that counterexample. What's the thing that proves this false? But we don't have any in this case, again, because a leap year is always going to have 29 days and vice versa in February. So this example here, everything's true. In the next one, though, in example 2, we're going to come back, we're looking at that converse again from 3.5. This is the conditional statement given to us at the beginning. So this is the conditional statement right here. If you are 16 and older, then you can drive. What it says is to say whether or not it's true or false, and then also to provide the converse, inverse, and contrapositive. And all the while stating whether those are true or false. So if you are 16 and older, then you can drive. And there's some open to interpretation here. But let's talk about the ability to like, it's possible for you to drive. So like talking about all these things with having a license and so on. So you might say this is false. And the reason for that might be that you need your driver's license. So it's just not automatic that you can drive when you're 16. So there's a counterexample. Let's do the converse. So remember from 3.5, the converse is when the hypothesis and the conclusion get flipped around. So we'll write the converse here. If you can drive, then you are 16 or older. So let's think about what this means here. If you can drive, so we think about somebody driving, could be you. Does that person have to be 16? Does it automatically mean that person is at least 16 or older? So you think about any driver that's on the streets out there driving around. Yes, they would have to be 16 or older. And again, we're talking about, there's some interpretation. I would see it as, I guess you could say you need your learners and so on. But we'll say driving by themselves and that kind of idea. Then yes, you have to be 16 or older. So this is going to be true. If it's true, you don't have to provide an example. It's only if it's false you need to provide a counterexample. So the inverse of this then, the inverse of the conditional statement, remember that's when we negate that conditional statement. So the inverse here then would be back to this conditional statement here. We're going to negate that. So the hypothesis and the conclusion will add a not. If you are not 16 and older, so here we go. If you are not 16 and older, then you cannot drive. So that would be the inverse. Well, is that true or false? So think about this. If you are not 16 or older, so let's think about and again, we're talking about driving alone, and I guess I could be more specific. Maybe you interpret this differently. But if you think about someone who's not 16, because it says if you are not 16, so maybe you yourself aren't 16. I think you mostly would be. Or you have a sibling, someone who's not 16, then they cannot drive, right? They're not going to be driving alone. They don't have that ability. So if you're not 16, yeah, it means you can't drive. So that would also be true then. And again, if it's true, you don't have to provide an example. The contrapositive, so let's write that. And again, you can get to it, so to speak, if you start with the conditional statement and you go to the converse and then to the contrapositive by just negating and putting a not in the converse. So you're taking the converse and you're negating both the hypothesis and the conclusion. Or, like we saw in example 1, you can get to the contrapositive by taking the inverse of it, of the conditional statement. So we've already had the not in there now. You can see the not there already. And then flipping it around. So sort of taking the converse of that. So then you get here by switching the hypothesis. The hypothesis switches with the conclusion. So either way, we look at it, we can see we get there either way. So let's see what that looks like for our contrapositive then. So if we take the converse here, so we're looking at the converse, getting the contrapositive. If you cannot drive, then you are not 16 and older. We think about whether or not that's true or false. Well, if you cannot drive, so think about somebody who cannot drive right now. It could be like, in my case, it could be my grandma, right? She cannot drive because she doesn't have her driver's license, but she is 16 or older. So it doesn't automatically mean that you're not 16. It could, again, there's that driver's license component to it. Or maybe someone is injured. They have their driver's license, but they're injured. They're unable to drive for that reason, not because it's not just because they're not 16 yet. So this would be a false statement. And because it is false, we need a counterexample. So that would be the same thing. So if you cannot drive, we could say they don't have a driver's license, so same thing. Or maybe they're injured. And you can see that the same sort of trains of thought we're going through with the contrapositive are very similar to the way we were thinking about with our conditional statement. So we'll talk about this at the end of the notes here, but we can see that these things featured a similar mindset when we're trying to process if it's true or false, and these things featured a similar mindset when we're trying to process whether that's true or false. So we'll come back to that. Another example here, if a polygon has 5 sides, then it is a pentagon. Again, this is the conditional statement here. So if a polygon has 5 sides, then it is a pentagon. And you have to remember some things about geometry, but there is no other 5-sided thing than a pentagon. So a 5-sided thing, it will be called a pentagon, and this is true then. And if it's true, we don't have to provide a counterexample. The converse, we flip the hypothesis and the conclusion. So we say, if a polygon is a pentagon, so we're writing that first now, then it has 5 sides. And again, these things go hand in hand. If you have a pentagon, that means it has 5 sides. Just like if you talk about a square or a quadrilateral, it means it has 4 sides. An octagon means it has 8 sides. So the name of that refers to actually the sides that it has. So this is also true. And so we don't need a counterexample. The inverse, back to the conditional statement, remember that's when we're putting the knots on here. So we're taking this and we're adding the knot from the inverse. So if a polygon does not have 5 sides, then it is not a pentagon. So we're adding the knots in there now. And again, we talked about a polygon that's not 5-sided, so like a 6-sided figure. Well, then it is not called a pentagon, so that's true, right? And there's other things that we could refer to with that. but we don't need to provide those examples. We only need to if it's false. Lastly, the contrapositive, that can come from the converse or the inverse. Last time we talked about it coming from the converse. Let's see how we can get there from the inverse. So if we go from the inverse to the contrapositive, we take that statement, if a polygon does not have, so this one here, does not have 5 sides, then it is not a pentagon, and we reverse the hypothesis and conclusion. So if a polygon does not have, back up. If a polygon is not a pentagon, then it does not have 5 sides. So we think about whether that's true or false, and you think about something that's not a pentagon, again, it goes both ways. This is also true. Now, it does hold true that if the conditional statement was true, this is also going to be true, the contrapositive. They go hand in hand. If the converse is true, the inverse is also going to be true. So just like we did that and saw that's the case with example 2A, I guess. Also see that it is the case in 2B, even though everything is true. But we can fill the blanks in then with the with that relationship. So it says if a conditional statement is true, then its contrapositive is true. So contrapositive goes with conditional statement. The next one, if the inverse is true, then the converse is true. The inverse goes with the converse. And you notice that these are actually conditional statements, right? If, then, but either way, those are actually, you could say they're biconditional statements. If the converse is true, then the inverse is true. You could say if the converse is false, then the inverse is false. There's this relationship. Okay, so obviously 3.5 and 3.6 very much tied together. You can't really work with 3.6, the inverse and the contrapositive, without the terms and the knowledge from 3.5, the idea of the converse and so on. So as you're working on this, you might want to do it all at once or break it into pieces, but I will have textbook questions that you can use to kind of process this a little bit. And as always, let me know if you have any questions with this. So this concludes chapter 3, and I will give you more information as to what the next unit looks like and what we'll do with that.